All right, so let's kick things off with a bit of a riddle. What on earth could a multi-million-dollar space telescope and that buggy game on your phone possibly have in common?
The common thread, Alex, is software failure. And, as you can see here, the fallout isn't just a minor annoyance. We're talking about huge amounts of money lost, reputations completely trashed, and sometimes it can get incredibly serious. The stakes are just so high.
And this really gets to the heart of why we test. See, the cost to fix a software bug isn't a straight line. It goes up, like exponentially, the later you find it in the process. A tiny fix during the design phase might be almost free, but that exact same bug, if it makes it out to customers, it could cost thousands, maybe even millions to sort out.
Okay, so it's obviously super important. But what are we really talking about here? Can we pin down a solid definition of what software testing actually is?
Yeah, absolutely. At its core, testing is a systematic process. It's not just, clicking around hoping something breaks. The whole point is to evaluate a system to find defects. And a defect is just a gap between what the software is supposed to do and what it actually does. It's all about managing risk and giving the whole team good information about the quality of the product. And we basically tackle this in two major ways. You can think of it like building a house. On one hand, you've got static testing. That's like reviewing the architect's blueprints before anyone starts building. You're looking for mistakes in the plan itself. Then you've got dynamic testing. This is when you're actually running the code. It's like taking the car for a test drive to see how it really feels on the road. You need both. Now, this next idea is so important because it's a really subtle distinction. We have verification, which asks, are we building the product right? Does it match all the technical specifications? But then there's validation, which asks a way bigger question. Are we building the right product? Does this thing actually meet the user's needs? You can perfectly build the wrong thing.
And it's important to remember that bugs don't just magically appear. There's a whole chain of events. It almost always starts with a simple human error. Maybe a developer misunderstood something or was just having an off day. That little mistake creates a fault or a defect inside the code. But it only becomes a failure, the thing the user actually sees, like a crash, when that piece of code is run.
So to make sense of all this, testers operate by a kind of code, a set of core ideas. These are pretty much the 7 foundational principles that every great tester has ingrained in their mind. And the first one is a real mind-bender for a lot of people. Testing can prove that bugs are there, but it can never prove that a product is completely, 100% bug-free. No matter how much you test, a bug could still be hiding somewhere. The real goal is to lower the odds of that happening.
Okay, wait a second. I gotta push back on that a little. Why not? I mean, with all the computing power we have today, why can't we just test every single possible thing and prove it's perfect?
That is the perfect question, and this slide is the perfect answer. Let's take this example of a dream car configurator. Just a few basic options, models, engines, colors, and you're already at 150,000 different combinations. But what happens if you add just 50 more optional extras? The number just explodes. We're talking quintillions of possibilities. It's just not physically or financially possible to test every single one.
And that is exactly why testing is all about being smart, not just thorough, which leads us to these next principles. Number 3, we've already covered. Test early, save big. Number 4 is about where to look. Defects love to hang out together. It's an 80-20 rule. You'll often find 80% of the bugs in 20% of the code. Then there's number 5, the pesticide paradox. If you keep running the exact same tests over and over, they stop finding new bugs, just like pests becoming immune to the same pesticide. And finally, number 6, context is everything. You test an e-commerce site very differently than you test the software for a pacemaker.
Okay, and this last one, principle number 7, kind of brings everything full circle. It's called the absence of errors fallacy. It means that you could have a piece of software with literally 0 technical bugs, but if it's confusing to use or solves a problem nobody actually has, it's still a total failure.
I've got to be honest. My mental image of a tester was always just someone randomly clicking around an app, just trying to break things. But this sounds way more scientific.
Yeah, that's what a lot of people think. But no, it's a real engineering discipline. There's a whole structured process here, from planning all the way through to completion. It's a constant cycle of analyzing requirements, designing smart tests, running them, and then reporting on what you found.
And to do that process well, you have to wear a completely different hat. You need a different mindset.
A developer, they're in creation mode. Their job is to build a solution that works. But a tester, they're in investigation mode. Their job is to question assumptions and look for potential problems.
And this really gets to the heart of what that tester mindset is all about. It's built on these skills. Of course, you need a critical eye and attention to detail, but you also need deep curiosity, empathy for the user, and this is so important, objective communication. It's never about pointing fingers or blaming a developer. It's about delivering clear, factual information so the team as a whole can make the product better.
Wow, so it's not just about hunting for bugs at all, it's a whole discipline with its own philosophy and psychology.
Exactly. Which really leaves us with this big question to chew on. If we accept that a perfectly bug-free product is a myth, then what does quality actually mean? It's not just a lack of errors. It's a really complex balance of making sure the software works, is easy to use, and actually delivers real value to the person using it.